In this video, I'm going to discuss the empirical rule using example 6.6 from the Introductory Statistics OpenStax book, which is available for free using this link here. Okay, so I'm going to first talk about what is the empirical rule, and then I'll go through that example. So the empirical rule, it's often referred to as the 68, 95, 99.7 rule. Okay, and it says that if, say, x is a random variable that's normally distributed, right? So x is normally distributed with mean mu and standard deviation sigma. Then all possible x values within one standard deviation of the mean, 68% of x values will be within one standard deviation from the mean. Okay, that's where the 68 comes from. Then you can start to guess what I might say within two standard deviations from the mean. Two standard deviations from the mean, right? The next number is 95. Yep, 95% of all possible x values will be within two standard deviations from the mean. Okay. Lastly, within three standard deviations from the mean, if x is normally distributed, then all possible x values within three standard deviations of the mean, 99.7% of all possible x values will be within three standard deviations from the mean. Okay. Okay, so now how do we use that in an example? Okay, so let's go ahead and read through this. From 1984 to 1985, the mean height for 15 to 18-year-old males in Chile was 172.36 centimeters. Standard deviation was 6.34 centimeters. Okay, we're going to let the random variable y denote that height, and so y is normally distributed with mean 172.36 and standard deviation 6.34. All right, so if I were to let's draw out this distribution. Okay, it's normally distributed. The center, we have the mean 172.36. Okay, now if I were to go one standard deviation below the mean, right, 1 sigma, and one standard deviation above the mean, 1 sigma, the empirical rule says that 68% of all possible, y values in this case, all possible y values will be within one standard deviation of the mean. Okay, so this first question says about 68% of y values lie between what two values? Basically, I need to figure out what are these lines, right? Where is one standard deviation above and below the mean? Okay, so to go below the mean, I would need to take the mean, 172.36, and I would need to subtract off one standard deviation. So a standard deviation is 6.34. If you do that subtraction, you'll get 166.02. Okay, next, if I want to find one standard deviation above the mean, I would need to take the mean and then add on one standard deviation, right? And that'll give me 178.7. Okay, so between what two values? The values are 166.02 and 178.7. All right, the z-scores. What would the z-scores be? The z-scores, remember, is the number of standard deviations from the mean. So one standard deviation below would be a -1 z-score, and one standard deviation above would be a +1 z-score. Okay. All right, next, what about 95% of the y values? Where do they lie between, right? So if we know that if we go two standard deviations away from the mean, so two standard deviations away from the mean, then 95% of the data, 95% of all possible y values will be within two standard deviations from the mean. Okay, so how am I going to figure that out? Well, start with the mean, 172.36, and then subtract off two standard deviations to find this lower value. So minus two standard deviations, minus 2 times 6.34, okay, which is 159.68. So this value right here is 159.68. 0.68. Okay, next to find the upper limit where 95% of the data is between, we would take our mean, 172.36, and then add on 2 standard deviations. Okay, add on 2 times 6.34, and you get 185.04. 185.04. Okay, so about 95% of the y values lie between what two values? 159.68 and 185.04. Okay, what's the z values for those guys? Since we're going 2 standard deviations above and 2 standard deviations below, it's -2 and +2. Okay, lastly, what about 99.7% of the y values? What does that lie between? So if I were to go out even further, 3 standard deviations away from the mean. 3 standard deviations away from the mean, both above and below. Okay, so to start, let's find the lower part. Okay, so if I were to take 172.36 and subtract off 3 standard deviations, okay, and do this math, I'll get 153.34. 153.34. And if I were to take the mean and then add on 3 standard deviations, plus 3 times 6.34, I would get 191.38. So this is 191.38. Okay, so the two values are 153.34 and 191.38. The z-scores, since I'm going 3 standard deviations below and 3 standard deviations above, would be -3 and +3.